Hey guys, it's Casey and welcome back to another tutorial. Today we are going to be doing a tutorial on I guess we're gonna link this to kind of like the Zelda mechanics of how you could like pick up a pot, you could hold it over your head and walk around, and then when you clicked you would throw it, it would smash, and we can make something pop out of it. So it's gonna be a pretty simplistic tutorial. We're just looking for like those base mechanics. This will be our end result, is we just want to be able to walk up, pick up an object, run around with it, and then when we click again we can throw it, it'll smash, and then we can pop out like a ruby or coin or whatever happens to pop out. So that's kind of our end goal, is going to be that. It's going to be a pretty simplistic tutorial. So what we're going to use as the basis is this third person, just the default third person template. As setup, you want to activate the Destructible plugin, which if you go under Edit and go under Plugins, and if you go under the built-in, we want to search for Apex. And you want to turn on this Apex Destruction plugin if you want to be able to use the destructible meshes. If you don't want to do that, you don't have to enable this. It's just I'm going to be using, as the objects we pick up, I'm going to be using the destruction to break them apart. So activate that if you want to follow along. It's going to make you restart when you activate that. So we're going to do this tutorial a little differently. Normally I go from the very beginning and walk through it, but I've done a very small amount of setup here. And what I've done is I've made three very simple, basic, pretty bad animations, honestly. As I say in a lot of my tutorials, I am not an animation artist. Please don't hold me to them. But I made three of them. You can see here we have a lift, we have a hold, and we have a throw. So inside of the lift, if I pull it over, this is what my lift basically is. Very simple. I would say there's a few special things going on. The first thing I did is, if you see here at the bottom, this animation where my mouse is, it's 1.3 seconds. But if I kind of move this forward all the way up to half second, you can see nothing is happening in my animation. And I did that on purpose, and I'll show you why in a bit. So I guess like the first part is on my lift. For a half second, nothing happens. And then I have a notify set up here, and if you right click inside of an animation in this notify section, you can add a new notify, and I did one for picking up, and then the rest of my animation is simply just my character lifting up. That is my lifting animation. My holding animation is simply just the last second of this keyframe, like this last little frame with me holding it up. It's just that, but still, there's only one frame. It's basically a pose of him just holding it over his head. That's my holding animation. And then my throwing animation is, once again, super simplistic. I just bring it back. If I could drag this, I just bring the arms back and I bring them back forward. That is literally my animations. And then in the throwing one, like we did in the picking up, where I think my player should release, or my character should release the object that we're picking up when throwing, that's where I have this throwing marker here. Once again, it's just a notify. You right click, notify, and I added a new notify and I named it throwing. So that's what that is, and right where I'm at that state of wanting to throw, I just added a notify there. So that's our setup, or that's my pre-setup that I've done. I just made these quick three animations. They're really crappy, but they're going to articulate what we're doing fairly well. And what we're going to do first, I believe we're just going to set up our animation blueprint first. I believe we can do that because, in my opinion, we know what our end goal inside of our animation blueprint is. At least I do. So what I'm going to do is I'm going to navigate to my animation blueprint. To do that, I'm just going to do filters, do animations. If I can check that, here's my animation blueprint. It's third person Annum, or _ Annum BP. So let's open that up. So the reason I say I know what I want my animation blueprint is, to get to your base state, you need to select one of your animation states here, and you just need to hit the back arrow, and now we're at our main graph area. The reason why I say I know what my end is because I feel like this is fairly simple. I know from my idle position, I want to add a new state, and I want this to be picking up, or I want this to be like lifting, we can call it. And to transition to this, I know I want a Boolean. I know I want to feed to my animation blueprint. I know I want to feed it a Boolean, because later on we need to know when are we going into our lifting state. So I want to make a new variable, and we're going to call this, I'm just going to do undercase B and lifting, and I will save and compile. And then what we're going to do is we are going to transition to lifting when this Boolean is true. And then inside of our lifting, what I want to do is I want to use my lifting animation. But I know more than just using my lifting animation. I know that we might be walking a little bit, or we might be moving while we are lifting. So what I want to actually do is I want to blend this animation. And how I want to blend it is I want to layered blend per bone. And I'll explain what this means. What this means is that it's going to take two poses. We're going to feed it two different animations. And then based on these animations, we can actually, in the top right here with it selected, we can use these drop downs and we get a branch filter. And what we can do is if we hit this plus button, we get some more drop downs. And what it's going to ask for is it's actually going to ask for a bone. And we're basically going to tell it, in the base pose, I want it to use from our pelvis down. So from my character's pelvis, I want the base pose to be all of his legs. So if we're running around, we can use our running animation. And then what I want base pose 0 to be is I want it to be everything above the pelvis so that we can use the upper body from our lifting. And if I go into my skeleton, I just know above the pelvis is spine 01. That's just something that I know kind of by heart by now. So my layered blend per bone, I want this bone name to be spine underscore 01, and I want the blend depth to be 0. And then what I actually want to do is I actually want to go back, and instead of my idle / run, I'm just going to steal this little bit here. I'm just going to copy paste it over, and this is our running animation setup, and I just want to copy that over to our lifting, and the running should be our base pose, and the lifting should be our blended pose. And now if we hook that up, this should now mean that if we are walking while lifting, our feet will be moving like we're walking, but our upper body will still be doing the lifting. And then I just want to come in here, and I don't want this to loop. I don't want my lifting to loop, so if I click my lift, I want it to not loop, so I just want to uncheck that. And that should set up that. So what I want the next thing to do is I know from lifting, what are we going to do? Well, we're going to be holding it over our head. That's what I want our ending to be. So I'm going to add a new state, and I'm just going to make this our holding state. And I want to transition to this. If we go inside the transition from our lifting to our holding, I want to double click this arrow, and I want this to transition from lifting to holding when there's almost no time left in the lifting. So if I go into here and I type remaining, you can see here we get time remaining. Let's see, time remaining, third person idle, or no, we want the lift. Where is it? Time remaining lift. There we go. This is one that was highlighted. And what this means is that we can get the amount of time remaining left in that lifting animation, and I can say, hey, is there less than or equal to, let's say, 0.1 seconds left in that lifting? If that is true, then let's just transition to our holding animation. And I want my holding animation to be our hold, but once again, I don't want it to just be the holding animation. I want it to only be the upper body from the holding animation, and I want my lower body to still come from our walking. So I can literally copy paste the previous run plus the layered blend per bone. And if I copy that over, I can then just plug the hold into the bottom blend, and that'll make it so that our lower body is running and our upper body will be holding the cube up properly. So that'll handle that. And then we want one last state, and that's going to be our throwing state. I feel like to me this is pretty obvious. Like, I don't really have to do code before I start doing this because I think this is kind of obvious. If I want to pick something up, I need to lift it, and then once I have it lifted, I need to hold it, and once am done holding it, I need to throw it. So that's just kind of my chain of logic here. In our throwing, once again, I'm going to copy paste in the lower body, in that we just want to plug in the upper body from our throwing animation. And with that, that should set up, for the most part, at least the basis of the animations. And then what we need to do is we need to transition back from throwing back to our walking. And actually, we missed one more thing. To transition from our holding to our throwing, we need to make one more Boolean, and we need this to be a throwing Boolean. Or let's call it B underscore B throwing. Let's do that. And if that is true, then we will transition. So that was transitioning from holding to throwing. We made a new Boolean called B throwing, and I plugged that into this transition. And that we want to go from throwing to idle when there's almost no time remaining left in our throwing. So once again, inside of that transition, we can type remaining, and we get time remaining throw. There it is. And let's do less than or equals to, and we'll just do 0.1 seconds, and we will transition. There's a few things we missed, I believe. We want to make our throwing animation not loop, so let's turn that off. Let's not make that loop. And there's some transition effects that I want to do. Mainly, what I just want to do is I want to select this transition to our lifting. If you remember, inside of my lifting animation, for the first half second of it here, nothing is playing. The reason I did that is because I want to use the natural transition from our natural standing animation to our lifting animation. During this half second here, when we're leaning over, I want to make it so that we're naturally going down with our body so that we can start picking up. If this makes sense, I want this transition here. If I click on it once, on the right side, we get the blend. I want this blend to be a half second. And I'm actually going to set it to be, let's just set it to linear. So that means that for the first half second of this lifting animation, we're actually going to be blending into it, meaning we're going to go from our normal idle run to our lifting animation. But once again, we're going to blend for a half second. In the first half second of our lifting animation, we just so happen to not be doing anything, so it's going to look kind of natural. We'll see how this looks later, but to me, this is very purposeful to not have this first half second doing anything. So that'll set up our animation blueprint, at least for now. I believe that's pretty good. And now what we're going to get into is we're going to do the setup for the object that we want to throw. I'm going to reset my filters here so I can get back to here. And I want to set up a destructible mesh. So I want this destructible mesh to be the object that we're picking up and throwing, because I want this mesh, when I throw it and it hits the ground, I want it to shatter. And I just want to use a cube. So I'm going to search for cube. I want to use the cube with the chamfer. It just kind of looks nicer. And with that Apex plugin enabled, if I right click it, I can create destructible mesh. And with that, it opens up the destructible mesh editor. Maybe you've never seen this before. And all I really want to do is, I don't want to get too deep into how to set up destructible meshes, but I at least want to go through the very, 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 very basics. I just want to do this drop down that should apply the material. So I believe if you don't have the material showing, under the skeletal mesh setting, I believe you just have to drop this down and it'll enable that material. I want to enable two things. I want to enable impact damage, and I want to set the impact damage, let me look, I think it's 1000 as we want to use. Let me just look. Yes, it is 1000. And I believe that should set this up. Normally, I would be setting up a lot more settings in here, and that's more to deal with performance and like lifetime and stuff. I don't really want to get into that because I don't want this to be like a 20-minute tutorial on how to set up destructibles. I just want to do the basics. And if we hit this fracture mesh, we can see this is how our mesh is going to fracture. I like it, and I think we're good to save it there. So if I minimize this, what I want to do is I want to now take this destructible mesh, and I'm just going to drag it to my content folder just to get it in a place where I know it is. And I'm just going to do move here. So now in my base content folder, I now have the destructible mesh. I want to just drag it in my world, and I actually want to make this a blueprint. So what I'm going to do is I am going to, on this right side with it dragged in the world, I'm just going to make it a blueprint. It's going to say, hey, do you want to make this a blueprint? I'm just going to say, sure, create it. I don't really care about the name right now. Or actually, let's actually rename it. Let's call this our pickupable. Let's just call it pickupable. I'm fine with that. So now we have an actor, a blueprint actor created, and it is our pickupable mesh. So let's see, is there anything else we want to set up here? I think I'm okay with this. Let's see, is the size good? I think that size is a little too big for me. I'm going to set the size down. Let's do, I think we want to do like 0.7. I believe will probably work just fine. Let's do like 0.75, so let's make it 3/4 its size, just because I think it's going to be a little bit too big for a character. I'm going to drop that down into the world. So I like that. So now we have our animations at least set up, and I'll show you why we set them up the way we did. Then we also have our pickupable mesh set up, our pickupable destructible mesh set up. So now I want to go inside of our character, and I want to start doing our character's code. So with my character selected, I just want to go into this right side, do edit blueprint, and open up our blueprint code. So now what we're going to get into is we are going to get into kind of the logic of how we pick up our actor. So this is where I'm going to go into a little bit of a discussion. What we're looking for right now is we need to get a reference for when we can pick up destructible meshes, if that makes sense. We want to know, like with our character, when we walk up to this mesh, we want to know that we're next to it. And there's a bunch of ways that we can do this. I had to stop, and actually before I thought out this tutorial, I had to stop and really think about what is the best way to do this. Because in theory, we could do a line trace off of our character to see when there's an object we can pick up in front of us. We could put an overlap box that's attached to our character and put it just in front of us to know when we need to pick things up. We could put an overlap box on our pickupable mesh. If, like, say this was like a vase or a vase inside of Zelda, in theory we could put like an overlap box around it to know when we're inside of it. And the honest answer is, I don't know if there is a good answer, because there's pros and cons to all of them. One of the cons that I can think of, and the way we're going to end up doing this is we're going to end up doing a line trace. I like the line trace because it makes us know exactly when there's something in front of us. we get a hit actor reference and we can check to see what it is. But the issue is that if you wanted a ton of functionality in your game, say you wanted to be able to pick up like a vase in your game, say you wanted to be able to pick up, maybe there's like a turnip in the ground and it's like also for farming and you could like pick it up and hold it over your head. Say you wanted to be able to pick up small enemies in your game. That all requires different types of actors, and that's kind of an issue, kind of. Because I don't want to make this too complex, but essentially there is kind of a reason maybe to do an overlap box around our mesh, but the issue is if we have an overlap box around of all of our pickupable items in our game, say we're in a room with like 10 enemies that we could potentially pick up, and also maybe like 50 crates in our room that we could potentially pick up and throw, you're gonna have a ton of overlap boxes everywhere. That's not so good for performance. On the other hand, doing a line trace on tick maybe isn't the worst thing in the world, but there are drawbacks to it, to where if we have too many different types of actors that need to be picked up, we need to know what can be picked up and what can't, and that might lead to a bunch of casting. It might lead to maybe using like interfaces, and we need to know when something's using an interface. Essentially, this is a definite spot in code to where how are we going to know when we can pick up something, and that there's a bunch of different ways to go with it. And depending on how much functionality you want in your game, there's probably multiple ways to go with it. So that was my little rant on that. And this is one of those situations to where this is really a bunch of, the more pre-thought you put into it and the more figuring out you put into it, the easier it will be down the road, because potentially one way might screw you, not necessarily screw you, but make things harder on you later down the road, and you might need to change it. So that's just a little bit of a rant on that. I hope that made sense a little bit, but essentially there's a lot of ways to do this. So what we're looking for right now is we're looking to know when is that pickupable mesh right in front of us. So what I want to do is off of event tick, I want to be doing a line trace out in front of us to see if there's something we can pick up right in front of us. So off of event tick, I want to do a line trace for objects. Later on, and actually this is going to be slightly simplistic, you might want to do for visibility potentially. I want to make this super simple on myself, and I just want to do a line trace for destructible objects because that's what our destructible mesh out there is. However, if there is a wall in between us and that destructible mesh, this would still work. So potentially for your game, you might want to use a slightly different line trace. You might want to do a line trace by channel potentially and do it for visibility so that when walls are in front of you, it blocks. But for me, I just want to make this super simple, and I just want to search for a destructible mesh out in front of me. So now I'm going to do a very small amount of vector math. If doing line traces is something you're not used to, then I would advise watching my video on vector math because I think it's really important. So I want to get our actor's location, and that is going to be our starting location, and then I want to add to that our forward vector multiplied. So I want to get forward vector, get actor forward vector. That's a normalized vector, so I want to multiply that by a float. Let's say 100 units out in front of us, and what we're going to do is we're going to add that back into our character's location, and that's going to be our ending. I know there's going to be one slight issue with this, however, and that is this is going to be too high up in the air to detect objects that are down below us, so I actually want to subtract this get actor location by another vector. So off of this get actor location, I actually want to add a subtraction here, and I just want to subtract our z by, let's say, 30, and that's just going to lower it down because our actor location for a character is actually going to be out of like our chest, and if our crate isn't high enough to be out of our chest, this is going to be a little too high. So I just want to lower it by, let's say, 30 units. You might need to do it more. That's up to you. That's going to be kind of within your game. And off of this trace, we want to do a branch to see if we hit something, and if we hit something, we want to get our hit result. And off of this hit result, this is kind of where what type of game you're making and how you want to get your actors references matters, in that we just want to cast to our pickupable mesh. If you had multiple things that you wanted to pick up, and say you wanted like a vase you could pick up, you wanted an enemy, potentially you wanted some inventory items that you could pick up and hold over your head all the same, you might need to be doing multiple casts. And that's where this kind of comes into, do you want to use an interface? Do you want to use casting? And if you're more experienced, what I'm talking about probably makes a lot of sense. If not, I guess don't worry about it too much, but know that this is where your code might differentiate down the line when you need to add more functionality. You might need to do something else than a line trace here. Just gonna highlight that for you. So if we do it, so on tick, we're doing a line trace out in front of us, and we're searching for destructible actors. If we do hit something, we're going to see, is it destructible? And if it is destructible, we want to make this a variable. We want to promote this to a variable. This actor reference that we have now, I'm going to promote that, and I'm going to name this, let's call it our pickup target. So this is going to be, if we're hitting something and it's right in front of us, we're just going to save that, and we're going to call it our pickup target. But not only do I want to save this as our pickup target, I want to do a branch here right beforehand, and I want to say, hey, do we currently have a pickup target? And if we do, is it equal to this one that we're currently hitting? And if it is the same thing, I just want to set this to be false. So let's say I walk in front of our destructible mesh. If I'm hitting this destructible mesh 60 times a second, I don't want to be running our code 60 times. I just want it to say, hey, is this pickup target that we just set, is it equal to the previous one that we had? If so, I don't want to be doing anything. I just want to say, okay, we already had him stored. Let's not worry about it. But if we don't, then I want to set this to our new pickup target. And what I actually want to do now is I want to make a widget. And I'm just going to make a very simple widget, and I just want to this to be kind of our notification for when we're hitting something. And this is also kind of like in the bottom right, I believe in the Zelda games, when you walk up to like something you can pick up, it pops up a little HUD that says press A to pick up or press B to throw or something like that. I forget what it says. But I'm just going to call this like my pickup widget. I'm just going to name it fairly standard. And I'm just going to add a very simple text box in kind of the bottom right corner here. And I'm just going to name it like press A to pick up, exclamation mark or something like that. And that's just going to be my notification when we're in front of something. This is normally where you'd show like the button presses and you'd give some like information to the player. I want to wrap my canvas panel in a size box, and then I want to wrap my size box in a scale box. I did that a little fast, and I apologize, but the reason why we're doing this, did they get rid of scale boxes? Nope, there it is, wrap with scale box, there we go. So the reason why I want to do this is you wrap your canvas panel in a size box, and then you right click and wrap that in a scale box to scale your HUD or your UI to match any resolution. And then with my size box selected in the top right here, I want to do these check boxes for the height, width, and height override, and I'm just going to make it 1920 by 1080, and that matches my monitor resolution personally. So now this will scale to our tiny little screen here in the viewport. So what we want to do now is we want to add that to our viewport when we do get a target to pick up. So what I want to do is if we do hit something and we want to pick it up, I want to create a widget, and I want that widget to be that pickup widget that we just made, and I want to add it to our viewport, and I also want to promote this to a variable. So let's promote that, and this is going to be our pickup widget reference is what I'm going to name it. And now with this promoted, what I actually want to do is I actually want to do one more check, and that is after we set our pickup target, I just want to get our pickup widget reference, and I just want to do an is valid. The reason being is that potentially we could look at multiple objects that we want to pick up, and we could see how we would be setting this over and over. I don't want to add multiple of these widgets to our screen. If we already have one on our screen, sorry, I want to set that to is not valid on this is valid check. If we don't have a widget, then I want to create one and put it to our screen. But if we already have it put to our screen on this is valid, I don't want to do anything. I don't want to create another widget and add it to our screen. I don't want to do that. So that's the reasoning there. So I believe we can test this code out. The one last thing I'm going to do before we do that though is I'm just going to, on our line trace, I'm going to set this debug to be for one frame so that we can visualize our line trace. So I believe we're good to go. So on tick, we're going to be doing a line trace out in front of us, and if we hit a pick upable object, and we don't currently have one, then we're going to set that object to be our target, and and if we don't have a widget created, we are going to add a widget to our viewport. So let's try that out. So you can see that red line kind of in my knees, if you can see that there, that's our line trace. It's for us searching if there's a pick upable object. And when I walk up to this, you can see we hit, and you can see in my screen it popped up the text and it said press A to pick up. So this is working nicely. So what I want to do now is I want to say, when aren't we hitting a target? So let's go off of this false here. So when we are doing our line trace and we aren't hitting a target, we also want to do something. And what we really want to check for is with this pickupable target variable, we want to do an is valid check on it. So what we're basically asking ourselves is, either with our line trace, if we're not hitting anything, so on this pin, Or if we do hit something, but it's not an object that we want to pick up, so on this cast failed, I want both of the pins to go into this invalid. In either situation, if we currently have a target stored, but we aren't currently hitting one that we can actually pick up, then I want to clear out our reference here. I want to say is if we do currently have a pickup target valid, but we're currently not hitting one, so if that is valid, then I want to set that to be nothing. Doing a set with no pin and plug it into it basically clears out this target variable. And then also I want to say, hey, do we currently have a widget? Do we currently have a widget popped up on the screen? And if we do have a widget popped up on our screen and it is valid, then off of this pin, I want to remove from parent. And what that does is that clears out our widget from our screen. And then I also want to take our widget and just set it to be blank. And that should make it so now when I walk up to our mesh, so actually I'm going to unhook that code real quick for example purposes. Don't unhook it yourself. I'm just going to alt click this is valid to clear it. I'm going to show you why we're doing this. The reason being is that when I walk up, you can see we hit it and our widget pops up, but when I walk away, you can see how our widget is still there. What this code we just set up does, so if I hook back up that false and that cast failed, what that should now do is that should clear out our target and it should remove that widget when we walk away from that target, when we're no longer hitting it. So when we hit it, it pops up our widget, and then when we walk away, it pops away our widget and we clear out our target. So that's just some simple checks there. And I like this code. For the most part, I like this code. So I think what we can now do is we can ask ourselves, when do we want to pick up our object? So I'm going to check my inputs. I believe we don't have any default inputs made for our clicks. So what I'm going to do is I'm going to do edit project settings, and then on the left side I'm going to go down to my inputs, and under my action mappings here I'm going to check, and yet we don't have any clicks made, so I'm going to add a new one by hitting this plus sign. I'm actually add two, and on the first one I'm going to name it, let's name it just left click, and the second one I'm going to name right click. I don't know if we'll use right click, we probably won't, but I'll make it just in case. And then under our left click, I'm going to do the drop downs. I'm going to make this our left mouse button. I'm going to make the right click our right mouse button. And what that now does is we now have inputs for our player on left click for our left mouse and our right click for our right mouse. So if we go back into our character, we can right click an open space and we can search for left click, which is the name of that event we just made. And now we have a left click event. So what I want to do with this left click event is I want to ask ourselves, when we left click and we want to pick up our mesh, I want to know if we have a target stored. So remember, when we hit a pickupable target, we stored it as a variable. And what I want to do is when we left click, I want to make sure we have a variable stored. So what I'm going to do on our pickup target is I'm going to do an is valid. And I'm just asking our game, when we left click, are we currently looking at a mesh that we can pick up? That's basically what we're asking ourselves. And if we do have a mesh that we can pick up, then what I want to do is I want to then communicate with our animation blueprint and start doing our lifting. So what I'm going to do inside of my third person character is I'm going to search for event begin play. Let's see. Oh, there it is. So we didn't already have one. And what I want to do is I want to get a reference to our animation blueprint because I want to manipulate its variables. So inside of our character, what I'm going to do is on event begin play, so at the start of our character when he's alive in the world, what I'm going to do is I want to drag a reference to our mesh out into our space here, and then off of this mesh, and if I type Annum instance, you can see here we get Annum instance. And what our Annum instance is it's a reference to our animation graph. But it doesn't know what our animation graph is necessarily, so we need to cast it. And what we want to do is if I type cast, we get cast to third person Annum BP, and if you look in the top left here, that's the name of our animation blueprint. So what we get now is we get a reference to our animation blueprint, and I just want to promote this blue pin here to a variable, and I'm just going to call this Annum BP, so that whenever I want to manipulate or work with our animation blueprint, all I need to do is I need to use this variable that we have now stored. So when we left click and we have a target, I want to tell our animation blueprint to start lifting. So you remember we created at the start a Boolean called lifting. So that will transition to our lifting animation. So what we're going to do off of this is we are going to set B lifting, lift, did I spell it wrong? B lifting, no I spelled it right, that was weird. So what I want to do is if we have a pickup target, what I want to do is I want to set that to be true. And what I want to do is I want to store, instead of a pickup target, I now want to store an extra variable. So what I'm going to do is off of our pickup target here, I'm going to promote another variable. And I want this to be, I want it to be our picked up mesh. So now we have two variables here, a picked up target and a picked up mesh. So when we actually start lifting, I want to tell the game, hey, this is what we're currently holding. This is the object that we're actually picking up now. And we're going to store that separate from our target. But when we do start lifting, we're just going to store our target as our picked up mesh. And I believe that is okay for now. So let's try, actually, there's two more things I want to do. I know something buggy is going to happen when we start lifting our mesh, and it's going to interact weird with our character. So what I actually want to do is off of our picked up mesh, I actually want to do set simulate physics, and I want to set the simulate physics to be false. You can see it pops up our destructible component because that's the actual box inside of it. So I want to set its physics to not simulate, and that was set simulate physics. And off of this destructible component, I then want to do set collision enabled, and I want to set that collision enabled to be no collision. So when we pick up our box, I want it to be attached to our character, but I don't want it to do anything. I don't want it to interact with the world. I want it to just be calm. I just want it to chill out, if that makes sense. And what this should now do is that we should start our animation, and we should disable our physics. But there's going to be a slight disconnect. We're missing one more step here. So if I walk up and I get within range, if I click, you can see we start our lifting. But you can see we actually didn't lift it at all. And the reason being is that we need to tell our game to actually hold the box. So if we wanted to, I think a sloppy way of doing it is that right when we click, we could attach that box to our hands and it would just snap to our hands. But I don't like that because if you remember, when we start our animation, we have a half second of leaning over. So we lean over and then we lift up. I only want that box to snap into our hands once we actually start lifting up. And in my lifting animation, you can remember I showed you, in this moment that we actually started lifting here, which is about a half second into my animation, I added a new notify and I named it pick up. So what we can do is inside of our animation blueprint, if we go to the event graph up here in the top left, in this open space, what we can do is we can right click, and I called that notify pick up. I can right click and type in pick up. And you can see here, we get an event called Annum notify pickup. So what's going to happen is that this event fires when this second in that animation, or that moment in the animation we hit this notify, this will run. So what I actually want to do is I want to communicate back to our third person character, and I want to say, hey, we're in a moment that we're lifting up. So I'm going to create a new custom event. So I went back to my third person character, and if I right click and type custom event, I want to add a new custom event. And I want to call it, let's call it lifting final. I think that's fine with me. And if I compile and save and we go back to our animation blueprint, I now need to say over to our third person character that, hey, we hit this lifting event. So off of this try get pawn owner that was already here, off of our default code that was existent, what this is getting is this is giving the owner, this is giving the pawn that this animation is running off of. So what we want to do is we want to cast this to our third person character. And we're just saying, hey, is this pawn that is this animation blueprint is running on, is it our third person character? I know it is, but what we need is we need this blue pin. And with this blue pin, we can then call that lifting final. So if I save and compile and we go back over to our third person character, we now know the exact moment that we're starting to lift our hands. And with this lifting final, what I want to do is I want to attach the box to our hands. So what I'm going to do is with our picked up mesh, remember when we started lifting, let me actually reorder this code. So this is going to, if I comment this stores Annum BP. I'm just commenting this real quick. On event tick, we're searching for a pickup target. I'm just commenting this so that it's more visually appealing and you can understand it. Left click is player input. And that now what we're doing on lifting final is moments of lifting. And you can remember that when our player gave us the input to start lifting, we stored our pickup target that we're currently aiming at as our picked up mesh. And now with this picked up mesh, what we want to do is we want to attach to component. So if we attach to component, what we want to do is the component, so we're attaching our target is our picked up mesh. So we want to attach our picked up mesh. And what do we want to attach it to? Well, I want to attach it to our actual characters mesh. So what we want to do is we actually want to set up a socket to attach our cube to when we pick it up. So if I navigate to our skeleton, there's a bunch of ways to navigate to our skeleton. Inside of our third person character, if we clicked on our mesh and we double clicked our skeletal mesh over here, that would take us to our mesh. We want the skeleton tab up here in the top left. And what we can do here is that we want to say, where is that cube going to attach to? That's quite literally what we're doing with a socket. So what I'm going to do is I'm going to do a few things. Up in the top right here, I'm going to switch to my preview asset settings, and I want to set it from our preview controller to a use specific animation. And what animation do I want to use? Well, I want to use, let's say our holding animation. So now our character poses to our holding animation, and what I want to do is off of our right hand, so if I navigate to my right hand, I want to right click it and I want to add a socket. And I'm going to call this, I'm going to rename it, where is it? Do I just need to double click it? There we go. And I want to name this let's call it our lifting socket. I think I'm okay with that. And what I want to do is I actually want to add our destructible mesh, that cube, to this socket so I can visualize it. So if I right click my socket, I get this add preview asset. And you can see here we get our destructible mesh cube. So I can add it into the scene, and it's actually quite big. I wish we could scale it down. This is honestly a little bit bigger than what our actual mesh is going to be, so we're gonna have to actually just like work around this in theory a little bit. So I'm going to position this, I'm gonna try and position this where I think my character should be holding it. And you can see it's actually a bit too big and it's a little awkward. But let's see. We're going to do some trial and error in a second with this to get it perfect, but that's about right to me. That looks about fine, and now if we were walking around, remember it's going to be slightly smaller in the actual game when we use this, but that looks about right to me. I'd say that's okay. So when we lift it over our head, that's about right. That looks fine. So remember, we added a socket and we positioned the socket to where we want our cube to be holding, and we named it our lifting socket. So now if we go back to our third person character, what we want to do is our mesh is our parent, but then within this mesh, we want to name our socket our lifting socket. So let me double check. Back in our character, that was called lifting socket. Back in our third person character, lifting socket, I like it. Our location rules. We want this to snap to target on both the location. Actually, let's just do our location, and I think we want keep world on our scale. I think our rotation, we want our cube to keep its rotation. Actually, we won't keep world on both. Let's do that. We won't keep world on the rotation, we won't keep world on the scale. The reason being is I want the cube to snap location-wise to our socket, but I don't want to manipulate its rotation, I don't want to manipulate its scale. I want that to stay static. So I like that. So now let's test this out. So now what we should do is when we left click, we're setting our variables here. We're setting ourselves to be lifting, so we start lifting, we stop our cube from doing its physics and stuff like that, and that in our animation, when we hit this exact moment of picking up, we're going to run two different events, and our final event we run here is going to be this, and that's going to attach our mesh to our hands. So let's try that out. So if we walk up to it, we get in range, we click, you can see it snaps to our hands, and we have it lifted. And remember, we transitioned how we set up our animations before is that we made ourselves, if we navigate back to our animations here and use our debug, you can see we're in our holding animation. The reason being is that when we were 0.1 seconds left in our lifting, we transitioned over to our holding. So I like that. So this looks pretty nice to me so far. It looks okay at least. So do we need to reposition our cube? I would say I need to bring it forward just slightly. I need to move that socket forward just slightly and maybe just down. Maybe a little to the left and a little forward and maybe just slightly down. So I'm going to go back to my socket. I'm going to, let's see here. I want to move it a little forward. Did I say a little bit to the right? I forget. I think I said a little bit to the right. So let's move it right a little bit and then just a tad down. So I think that'll be good. So I think our socket is now in a good place. So what do we want to do now? So now that we have our cube lifted, we actually want to do some special things. So actually, let's make this look a little bit nicer, because there's a few things that are wrong with this, or at least that I think are a little bit wrong. And that is, if I kind of aim at like an extreme offset onto our cube, if I click, you can see it snap sideways to our hands. I don't really like that. What I would like to do is that if our character is kind of offset and in a bad position to pick up, I'm going to slide our character to be kind of in a perfect spot to actually start picking up. That'll make this animation look a lot nicer in my opinion. So what I want to do is that when we actually left click and we start doing our picking up, what I want to do is I want to move our character into place. And there's actually one more thing I want to do before we do that, and that is if I actually start lifting, if I left click, you can see I can run around while we were lifting, and that's really, really buggy. So the first thing I want to do is I want to stop ourselves from moving while we're lifting. So I'm going to add a new variable, and I'm going to call it inAnimation. And with this, I'm going to save and compile. And when we do left click here with our player input and we start lifting, I want to take this Boolean and I just want to set it to be true. And that's going to tell us that when we're in an animation and we don't want to be able to move, we want this Boolean to be true. And then what I'm going to do is I'm going to navigate over to our movement input here, the default movement input, and off of input axis move forward, I'm just going to do a branch, and I'm going to say, are we in animation? And if that is false, I want to move, but if we are in animation, I don't want to move at all. And I'm going to do the same thing down below, so I'm just going to copy paste that down, and I'm going to do that there too, and that I want that to be set to false and not true on our branch here. So if we're in the animation, we don't want to move. So let's test that out real quick. So when I click, I shouldn't be able to move. And you can see, yep, perfect, I'm not moving. I like it. So the next thing we want to do is we want to slide our character into place to actually pick up. So what I want to do is I want to do a timeline. So if you remember, the first half second of our lifting, we're not lifting, we're blending into our lift. So we have like a half second leeway to where we can actually slide ourselves into place before we actually start doing the lifting. That's another purpose of why I did that half second of dead time in my lifting animation. So with the timeline, I don't really care what it's called. I'm just going to call it half second just for my own purposes. I want this white pin not to be in play, but I want it to be play from start. And if I double click my timeline, I get this window, and I just want to set its length to be 0.5 seconds. And that should set up our timeline just fine. We don't want any more functionality. And what I want to do is off of this update, I want to set our actor rotation and location. So we get set actor location and rotation. I want to slide our character into place over a half second to the perfect position to pick up our object. So the first thing I want to do is I'm going to do some math for our location. And once again, I don't want to explain this vector math too much, but I'm going to explain it a little bit. And if it really doesn't make sense to you and you have no idea about vector math, I made a video on vector math and I really recommend watching that. So what I want to do is I want to put us in a position the perfect amount of distance away from our cube before we start picking it up. So what I want to do is I want to do off of this location, I'm going to work backwards a little bit because I think that might make more sense. And if I type interp, we want to interpolate. So we want to vector interpolate to constant. So what this will give us is this will give us this node. What I want to do is off of delta time, I want to drag off, and if I type delta, we get delta world seconds. That we plug that in there. I want my interp speed, let's do it to be 100, so that means we can move 100 units over the course of a second to kind of slide ourselves in place. Our current is going to be our current actor location, so off of that, if I do get actor location, this is where we currently are, the current, and now we're going to set up our target. So what I want to do is I want to know from a line from our cube to our player, I want to get, let's say, 100 units from our cube to our player. That's what I want to know, but I want that to be in a line. So this is slightly complex math, but what I want to do is I want to get a line that represents that direction. I know I can get a line facing from our cube to our player if I subtract our actor location of our player. If I subtract that, if I get our picked up mesh, and if I get this reference, if I get its actor location, I know if I subtract our actor, our current player, from our cube, that gives us a line facing from our cube towards our player. That's what the subtraction does. But what I need to do to it is I need to normalize it, and that gives it a magnitude of 1. And with a vector of a magnitude of 1, if I multiply it by a float, if you note here, this is very similar to what we're doing here with our line trace. This forward vector is a normalized vector. You can see it's a vector with a length of 1. We multiply it by a float, and that extends it by that distance. This extends it by 100 units here. We can do the same down below. We get a line, we normalize it, so that is this is just a vector representing a direction, and then we multiply it by a float that extends that vector by a certain amount. And now what we want to do is we just want to add this back into the location of our cube. And what this final piece of math here represents is this represents a location 100 units away from our cube in the direction of our player. So I hope that makes sense a bit. If that doesn't, vector math, I don't know how to explain it too much better than that. I tried to work through it. Very, very worth knowing vector math. If you don't currently know vector math, you'll use it a ton in video games, so I recommend learning it. So that sets up our location. So we can actually test that out real quick. Our rotation probably is going to bug out. So what I'm actually going to do, just for purposes of testing our location real quick, I just want to get our actor rotation real quick and just plug that in. Just for testing, you don't need to do this, but it's going to bug out our rotation if I don't plug that in real quick. So when I left click here, for a half second, our character should be like sliding into place for a better pickup. So if I click, let me actually slow-mo this. So if I open up my console with tilde and I type slow-mo, I'm going to slow-mo it down to 0.1. So we're at 1/10 of a second per frame. So if I left click now, do you see how our character is sliding into a better position to start picking up? That was the purpose of that code. It should help us snap a bit less. But honestly, I noticed we actually snapped a little hard there. We snapped to our hands a little hard. So I'm actually going to increase that distance just slightly. Let's do like 110. I think that's a bit closer to where we want to be. And for you, this distance is literally just going to be based on your own game. Based on your animation, the size of your object, the distance of your player, or how tall your player might be, this value here is going to be totally up to you within your game. If you want him to only be like 10 units away, you would set this to 10. If you have a massive giant character and you need that to be 1,000 units away, you would set this to be 1,000. This right here is the distance away that you want to be when you start picking up. So that's what that is. So now what we're going to do is we're going to set up our rotation. So once again, we're going to work backwards a little bit, and off of our rotation, if we type interp, we can do our interp2 constant. We can reuse, or we can actually just copy paste this delta world seconds over to our delta time. Let's set our interp speed to be 50. And by the way, if you want your character to rotate faster or slower, or slide faster or slower to that location, that's what the interp speed is. If we made our interp speed smaller, we would slide slower. Or if we needed to slide faster, we would up our interp speed, and that would slide us to that location a bit faster. So that's what that is. So what we want to do is our current rotation is our current actor rotation. And then what we want to do is we want to find what is the look at rotation from our player to our cube. So if we get our picked up mesh reference once again, what we can do is we can do a node. Actually, I'm going to move this to the side. What we want to do is we want to find look at rotation. So if you type find look at, we have a node called find look at rotation. And if we read it, it says find a rotation from an object or from a starting location to a target location. So we can literally feed it a starting location and an ending location, and that will tell us what the rotation needs to be to perfectly face that object. So what we can do is essentially we can get the actor location of our current player. That's our starting, and our ending is the location of our cube. So we can get actor location onto our cube, and now we know the exact rotation we need to be to perfectly face that cube. And that is simply going to be our target. However, I only want to rotate our player. A rotation, if we break it, and you need to break this also, you want to break this, it's three things. It's a roll, a pitch, and a yaw. We only want to spin our character to face the cube, so we only want to be working with the yaw. So what I want to do is I actually want to make a rotator, and I only want to use the Z here. We want to connect the Z's. We don't want to connect the X or the Y. We don't want to roll and we don't want to pitch. We just want to yaw our character to face the cube, and that return value is going to be our target. So let's test that out. So now when we click, what we should be doing for a half second while we're bending over is we should be sliding both our location to a perfect location, and we should be slightly spinning our character to perfectly face the cube. It's super subtle, but it's going to make it so that our pickup is much cleaner. So let's do our slow-mo again. Let's slow-mo to 0.1. And once again, I'm facing the edge of this cube. When I click, you can see I start rotating and I start slightly sliding to pretty much almost a perfect location to pick up that mesh. You can see there's a small snap there. So if we run it again without slow-moing it, let's see if we could recognize the snap. So I'm going to face the edge again. So let's see. That's not too bad. That snap is fairly minor, and what I would recommend is that you match this up perfectly. And honestly, the issue for the snapping might actually be because my cube is offset. I need to move it closer to my left hand. So I'm actually going to go back into my skeleton, and I'm going to move my socket a little bit closer to my left hand. So I'm just going to move that just slightly to my left hand, and I'm going to try this one more time. That might actually eliminate my snapping issue. That looks pretty good. That was a very minimal snap there. I like it. So now what we do is we slide our character into place, and it makes that pickup just look that much better. So now what I want to do is I want to come back into our character, and there's something I noticed. After I pick up my target, I can't move. And the reason being is that we never set that Boolean back to false once we're ready to start moving again. So back in my third person character, what I want to do is this moment that we snap the cube into our hand, I want to just set this in animation to be false. So that now when I pick up the cube and we actually snap it to our hands, I can start walking again. You can see here, I pick up and now I'm able to start moving again. So that fixes that issue. Whew, let's see, what else do we want to do here? Man, I need to get a drink. So let's see, is there anything else we want to set up for now? Let's see, are we missing anything? So I can see an issue. For performance reasons, when we already have a mesh picked up, I don't want to keep searching for a mesh to pick up, if that makes sense. So off of our event tick, what I actually want to do is I want to do an isValid check on a picked up mesh. So if we currently have a mesh picked up, I want to stop. I just want to stop off of isValid. I want to do that. So if we have a mesh picked up and it is valid, I don't want to be doing these line traces to find a mesh to pick up. I just don't want to do that. And one thing we can also do is that we can destroy our widget. So we can copy paste this code here, right here. So let's just copy paste that. This code is at the end of our pickup. And what we're literally just doing is we're saying, hey, is there currently a picked up or is there a widget currently on our screen to kind of tell us if we can pick something up? If it is, we're going to remove it from parent and set it to be false. I'm just going to reuse that code here and just plug that in on isValid. If you wanted to, you could actually make this a function, and we could actually do that real quick if we wanted. We could, with all that selected, we could right click, do function, we could do remove pickup widget. And what I could do is to reuse this, I could just drag this down here, and I could replace this code, and I can actually delete it, because this, once again, this has all that code encapsulated inside of it, so we can make that a function and reuse it if we'd like to. So now, when we actually have a mesh picked up, and we have a picked up mesh that is valid, we're going to stop doing our line traces, because we don't want to, that's a performance hint, we don't want to keep doing that. So that's why we do that there. So, what we want to do now is, we can do an extra check actually, and when we're left clicking, what we want to do is we want to make sure that we don't have a mesh currently picked up, because in theory we can spam left click after we've picked up our mesh and nothing stops us from doing so. So I actually want to do two checks. I want to see if we're currently in our animation. So if we're not currently in our animation, I want to be able to run code, but I want to do one more check, and I want to check to see if we currently have a mesh picked up. So I want to do an isValid on our picked up mesh, and if we're not in our animation and that is false, and we currently do not have a valid picked up mesh, then I want to do our pickup mesh code. But if we are in our animation to start picking up, then I don't want to run this code again. And if we do have a valid mesh currently in our hands, I also don't want to pick it up at all. So that's why we put those checks there. So what we can get into now is we can get into our throwing code. So what I want to do is I want to see if or when our player left clicks to start throwing. And when that is going to be is actually going to be right here. So if we left click and we're not currently in our picking up animation, however, we have a mesh picked up right here, then I want to be able to start throwing. So that's what we're going to check for right here. And what we want to do is off of this picked up mesh, if it is valid, then I want to start throwing. So what we want to do is off of this is valid, I want to communicate to my animation blueprint, and I want to set that throwing Boolean that we made, and I want to set it to be true. Because if you remember, if we go back to our animation blueprint, we made B throwing. What I want to do is I want to set that to be true, and that will solve that. So now what happens is when we left click, while we have our mesh picked up, we should start our throwing animation. So if I left click, there we go, boom. But you can see we didn't actually throw it, which is quite amusing. Let's see. Yes, that worked just fine. But what we want to do now is, just like we did with our lifting animation in our animation notify, if we go to our throwing animation, you can see I have that notify made, and that's at the exact moment that I think my arms are forward enough that I can start throwing, that I want to release that cube from my hands. So it's called, and it's a notify called throwing. To make a notify, once again, you just right click and do add notify, new notify. Inside of my animation blueprint, I want to go into the event graph, and just like we did with the pickup, I want to right click and I want to do our throwing. So if I type throwing, we get our Annum notify for throwing, and I'm just going to copy paste down this cast because we need it once again. And with this, I want to make a new event, custom event inside of our third person character, just like we did for this lifting final. I'm going to make a new custom event, and I'm going to call it throwing final. And if I save and compile, I go back over to our animation blueprint. Off of our reference here, I'm going to type throw, and you can see we have our throwing final. So now our third person character knows the exact moment that we start to release that cube from our hands. So what we want to do is we want to detach our picked up mesh from our character, because remember, when we lifted it, we attached it to our hands. What we want to do now with this picked up mesh is we want to detach it from actor. And what we want to do is we want to, I believe we want to just do keep world on all of these. We don't want to keep the relative, we just want to keep the world. That should be fine. And what we also want to do off of this picked up mesh is we want to set its collision to be enabled. So if I type set collision, we want set collision enabled. And once again, it's going to give us a pin for our destructible component. We want our collision to be enabled, so we want collision enabled. And then what we also want to do is we want to set our physics to simulate. So off of our destructible component, we can type set simulate, and we get set simulate physics. And we want that pin to be coming from our destructible, and we want to be simulating physics. That looks good to me. Now, there's something I'm going to do, but I'm not going to hook it up, because for some reason, I have no idea, it's been crashing my editor, and I don't know why. But what I want to do is off of this destructible component, I want to add impulse. And if I type add impulse, we get our add impulse here, and I want to add an impulse to our destructible component. And what you want to do is you should hook this up. I'm personally going to leave this just below because for some reason it's been crashing my game. I don't know why it's been crashing my game, and I'm really confused by it, but I don't think it should crash yours. It seems like a really weird bug to me. But what I want to do is I want to add an impulse to our destructible component, and what I want to do now is I want to feed it an impulse. And this is just going to be some math to tell it like what direction and how fast I want it to go. So if I right click and I do get actor forward vector, what I want to do is with that forward vector, I just want to add to it. I want to add a vector to it, and I just want to add just like a 0.01 to the z, or let's do a 0.1 to the z. And the reason why is that our forward vector is just going to be facing like directly forward in front of us. If I add the slightly to the z, it'll make it so that we have a little bit of height. We have a little bit of like upward force to our throw. That's all that does. And then with this, I just want to multiply it by a float, and let's just do something like 1,000. And this just represents the magnitude of the force. This represents the direction we're throwing, and this multiplication is just the magnitude of the force we're applying. If you want more force or less force, that's what you multiply here. You would increase or decrease this number. And to me, I'm not 1000% sure the results if we check this or uncheck this. I'd recommend fooling around with this. Try throwing with an impulse with this velocity change unchecked, and then try it again with it checked and see which one you like more. Because I believe, if true, strength is taken as a change in velocity instead of an impulse. So I would try both and see which one you like more, because I believe there may be some value to doing it one way or either. I don't think there's a definite answer to that. And then I'm not going to hook this up because to me it's been crashing my game. I hope it doesn't crash yours. It shouldn't crash yours. And then what I want to do is I want to then set our picked up mesh to be nothing, because once again this is us throwing it. Once we've completed the throw, I want to set this just to be nothing, just because I'm done with it. I don't want to reference it anymore. And that what I also want to do is, I actually don't think we did this, is when we actually start throwing, I missed one thing. When we start throwing, I want to stop our character. So to stop our character, we're just going to reuse this Boolean in animation. So once again, this is on our throwing code. So when we start throwing, I want to make it so that we stop moving. And that once we're done throwing, I'm going to set this in animation back to false. So I believe this should now make it so that when we left click with this mesh already picked up, it should throw it into the world and it should break because it's a destructible mesh. So let's try it. When we click, it releases, and there you go. You can see we throw it and it breaks. Okay, so our character is still doing his animation of throwing. So we have an issue there, and we actually have an error. Let's see here. Access none, trying to read property picked up mesh, third person character. Let's see, attach to component. So I believe we were spamming throw. So let's see, why did we get this error? Oh, okay, the reason why we had this error is because it was looping our throw. So we need to stop it from looping our throw. So why were we looping? Let's look over inside of our animation graph and let's see, on our throwing, did I not set this up at all? No, we did set it up, so its time remaining in the throw is less than 0.1. Did we stop our throwing from looping? We did stop it from looping. So I think what's happening is that we're going through to throwing and we're going through constantly maybe, all the way back. That could make sense to me. Let's see, the time remaining left in throw is less than 0.1. Here's our throw, so that makes sense to me. And the only way to go into throwing is if B throwing is true. So let's see here, were we ever setting throwing back to false? No, we did not, so we missed a little bit of code there. So let's see, give me one moment, let me just make sure. Let's see. Okay, I actually missed something. So what we're going to do is actually back inside of our animation blueprint, inside of the event graph, when we activate this final throw here, what I want to do is I just want to do it inside of here, and I'm okay with that. And I just want to set our lifting to be false, and I'm going to set our throwing to be false. And this is basically just going to reset our code, is essentially what it's going to do. Is that once we're like inside of that throwing state and we start to throw, those booleans that we use to go through this kind of this circle here, we're going to set them back to be false so that later we can reuse it. And that's just what we were missing. So on our Annum notify of throwing inside the event graph of our third person blueprint, we just want to set both of those booleans back to be false. And now I believe that should stop us from our chain throwing animation that we had there. So if we try it, we should pick up, we can walk around, and when I left click while walking, it should stop us and we can throw. And you can see it snapped it, it broke, and it smashes open. So I think that's a pretty good basis. I think, let's see, should we add just something small to this? Are we missing anything? Let me look at my code real quick and see, am I really missing much? I don't believe we're missing much. We're sliding into place. I like that. Our throwing code is throwing it just fine. We're picking up just fine. Are we missing any checks here? Let's see. On our left click, are we missing any logic holes that we might have? That looks good to me. I don't see anything that could potentially break there. Off of tick, we're doing it pretty cleanly. I like that. So I think that's pretty good. So I want to do one more thing, and this will just be a nice little just cherry on top. When our cube breaks, so when I pick up my cube and I throw it and it smashes, let's make something appear in its place. And this will represent like a ruby or maybe like a coin or something. So when it smashes, in that place where it smashed right there, let's make like a lootable that pops out of it. So what I'm going to do is inside this open space in our content, I'm going to add a new blueprint class and I'm going to make it an actor. And what I want to do is I just want to call this just our, let's just call it like coin or something like that. I'm fine with that. And then inside the viewport, I want to add a static mesh and let's just name it coin. And I believe what we can get is if I scroll down, I believe we have something like a torus or something like that. Let's see here. Let's see. Do we have it? If I search, how do you spell it? Oh my gosh, let's see. Oh, is it T-O? Torus, there we go. That's how you spell torus. So this kind of looks vaguely like a cube to me, so that's what I'm going to use. I'm going to rotate it so it's standing up. And with it standing up, I'm going to move it a little bit closer to the center. And then I'm going to scale this down a lot. I'm going to make this like 0.25 maybe. I want this to be tinier. Maybe that's too tiny. Actually, I think that could actually work. Let's try that out. I'm going to lower my snapping so I can just get this a little bit closer to the center. I don't need it to be perfect for example purposes, but I want it to be slightly closer. That looks about center to be. That looks pretty good. So let's use that. So with this coin, what I want to do is on tick, I just want to spin it just to make it look kind of fancy. So what I want to do is off of tick, I just want to do set actor rotation. And what I want to do is I want to make a rotation. And I just want to spin it on its Z. So what I want to do is I want to get our actor rotation, get our current rotation, break it, and then I just want to take our Z, our current Z, because I don't want to affect the pitch or the yaw, and I'm just going to add, let's say, like 2 to it, and then I'm going to set it, and that should just spin our coin constantly in space. So if we just drag that into the world real quick, actually, is that way too small? That is way too small. Let's actually up that a little bit. So that scale, let's set it to 0.5, maybe that's a bit better. So upping the scale slightly to make that bigger, there we go. So if I hit play, that should spin, there you go. So it just makes it a little fancier. Let's set up a little quick material. That'll probably make it look a little bit better. So I'm going to make a new material. I'm going to call it our coin mat. I'm going to go inside of it. I want this to be translucent. So on the bottom left of our material, instead of opaque, I'm going to do translucent. And then I just want to feed it a emissive color. So I'm going to do a constant vector 3 off of the emissive. I'm going to make it, let's just make it kind of red. That looks nice. And then I want to set the opacity. I want to just do a constant 1 on the opacity, and let's just set it to be like 0.7. So it's going to be slightly see-through. It's not fully see-through, but slightly, and it's going to be glowing red a little bit. I think that'll make it just look a little fancy. Once again, this is just a little cherry on top. This doesn't have too much to do with our picking up, but what we're going to do is now on my coin, on the right side with it selected, I'm going to change its material to be that coin material now. So now in our world with that coin, it should just be slightly red and it should spin. That looks a little bit nicer. Once again, this is just for example purposes. So I want to delete this. I want to spawn that coin when our mesh breaks, when this pickupable breaks. So with our pickupable, if we open up its code, if we select our destructible component and we scroll all the way down, we can get an event on component fracture. And this tells us when this cube breaks and it shatters into pieces, this event will fire. We can get the point that the spot in the world where it breaks. And what we want to do is we want to spawn actor from class. What is our actor? Well, our actor, we named it coin, so I can make it coin. What is the transform? Well, I just want to make transform, and I just want to get the location of this hit location. But I know that hit location is going to be fairly low on the ground, so I'm going to add Z to it, and let's just add like maybe like 50 Z probably will work, and that will plug into location. That add 50 just raises it up a little bit because that hit location is going to be on the ground. We just want to lift it just slightly. So now when our cube fractures and it shatters on the ground, we spawn a little coin that's spinning in its place, and that represents kind of like whatever lootable item, whatever pickupable item you wanted. So when we throw, it shatters, and there you go. It spawns, and its broken, shattered remains our little coin. So guys, I think that works. I don't think I'm missing anything. I think that's fairly complete. You could potentially find some holes in our logic here, like maybe a situation that we can throw when we shouldn't be able to throw, or a situation where we can pick up when we shouldn't be able to pick up. But I think this will work fairly well. Let's duplicate our pickup twice, and let's try it, and let's see if we can do this twice, and it still works. I think it should. So we can pick up, and we can throw, and we can pick up, and we can throw. That looks good to me. And I would say the reason why mine kind of falls like a limp fish is because I don't have that impulse hooked up. If I had this impulse hooked up, it should send it flying a little bit. But it's been crashing my game, and I don't know why, so I don't have that hooked up. But there you go, guys. This is personally how I would set up the basis of kind of a picking up and a throwing system. What the key to it, though, is that we want to attach it to our hands. Once it's attached to our hands, we just want to remove it from our hands and add an impulse through it, and that will do our throwing motion. From there, the rest is kind of up to you how you want it to behave. And once again, the really big part of where you can deviate in your logic would be, instead of doing a line trace to figure out when there's a pickupable object in front of us, instead of doing this, you might do overlaps. We could potentially do an overlap on our character to find out if something's in front of us. We could maybe do the overlap on the pickupable object on our cube to know when we're in front of it. All of them have their pros, all of them have their cons. I don't want to get too deep into that. I tried to explain it before, but no, that's probably where we would differentiate on our code. But that is the basics of it. That is at least kind of the math and how we can snap into location. And I think the part of making this look really nice is to try and match your animations to the code. And that's what I tried to do. Like if we kind of get to our side and we click, we kind of slide into place and rotate into place to try and make it so that the cube snaps to our hands nicer. And that when we don't throw right when we left click, we release only when we get to that part in our animation when we want to throw. And it's same with lifting. We don't immediately snap the cubes to our hands. We snap the cube to our hands when we start actually lifting our hands up in the air. So I think those details are what make it look and feel nice. So that'll be it for our tutorial. If you would like to see me do any other kind of gameplay mechanics from other games or common gameplay mechanics that you might see in several games, let me know. I'd be happy to do them. But that should do it for our tutorial, guys, and I'll see you guys in the next video.